Hey guys, welcome back to the series on multi-threaded programming and concurrency. Today let's talk about thread scheduling. So threads are schedulable entities, and user space applications ask, operative word here, ask the kernel to schedule threads for execution by the CPU. So in your program, when you create a new thread, you're basically sending a syscall to the kernel, asking it to schedule that thread for execution by the CPU. And we'll get into the operative word here, ask, in just a moment, and discuss very briefly some of the dangerous assumptions that can be made about scheduling threads. Thread execution typically does not affect the process, except if the thread segfaults. In that case, the entire process is terminated along with all of its threads. So if something goes horribly awry in one of the threads, the thread will segfault, and the entire process will be terminated along with all of the peer threads. One of the other scenarios in which thread execution could affect the process is with signals. So say a signal is delivered to the process by the kernel, like here we have the segfault signal, and it's also the same with interrupts, like if you press Control-C while a program is running in your terminal, the process terminates, not just the currently executing thread. So I want to make that very clear. If you're running a program that is multi-threaded and you happen to be on some arbitrary thread, probably that is not the main thread for the purposes of this example. So say you're executing some thread that is not the main thread, and the kernel receives some signal or interrupt, the process is going to terminate, not just the currently executing thread. So the kernel may schedule threads on multiple CPUs, contingent on schedule policies, such as first come, first served, shortest job. You could Google this. There are tons of scheduling policies for how CPUs are going to handle threads and how the kernel will schedule them. So an example scheduler, there's a single scheduler task running on a single core that controls what runs on all other cores. So in this scenario, you have a dedicated CPU core whose job is to manage which threads are running on which cores. And another example is a mini scheduler per core that schedules just that core. And if I remember correctly, I believe this is how Linux works. So the point here is that there are various scheduling policies, there's various ways in which the CPU schedules these tasks to run, and the takeaway I want you to have here is that it's kind of dangerous to make assumptions about how threads are going to execute. There's certain safeguards that you want to put in place if you're relying on different tasks or different threads to execute in a certain order, and we'll discuss that a lot. I say that a lot in these early videos that we will touch on this. I promise we will. We'll touch on synchronization, we'll look at mutexes, we'll look at thread barriers, we'll talk about condition variables, so we'll get into all of that stuff, I promise. So the takeaway here is that you cannot rely on ordered scheduling. Just because you create a thread T1 first does not mean it will execute first. This is a dangerous assumption. There's an entire category of comp sci dedicated to mitigating these types of issues, again, synchronization, and as I promised, we will learn about this. But for now, I just want you guys to have the takeaway that if you schedule two threads, so you create two threads by calling pthread create, T1 and T2, you absolutely cannot assume that just because you created T1 and T2 in that order, that is how they will execute. Now, chances are 99% of the time that is going to be the case. You say you create a program that creates two threads and you just run it over and over and over. You'll probably see that the first and second threads will run in that order, but there will be occasions, there will be occasions where it does not. And like I said, there is an entire field of computer science dedicated to this. So for now, all you need to know is that is not reliable. Do not rely on it. We'll talk about race conditions very soon, but for now, you cannot rely on ordered scheduling. Anyway, that's it for this one, folks. If you like this series, definitely like, comment, let me know what you think, and please subscribe. tons of new content coming. Definitely stick around for this series. We're going to get into some really cool, advanced, and sometimes obscure stuff with threads. See ya.